Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 20 from the May-June 2018 Edexcel IGCSE Mathematics A paper 2 higher, paper 2H. And this question here is about histograms, and we're told that this histogram shown represents information about the birth weights of some babies. So we're given this diagram here, frequency density. There's no scale on the frequency density given. And we're told that 6 of the babies here had a birth weight less than 2.5 kilograms. There's 2.5 there. So this area here, and also or greater than 4 kilograms. So this area here, together combine those two areas, represent 6 babies. Okay, so we have to work out the number of babies who had birth weights between 2.5 and 4 kilograms. So we need to work out the number of babies represented by the rest of these bars in this histogram. Okay, so now what we should understand is in a histogram, the height of the bar does not represent its frequency. The height of a bar represents its frequency density. And we haven't been given the frequency density here. Now we could, if we wanted to, work out the frequency density by using some sort of proportion, and then work out, the frequency densities of each of these bars, and then work out the frequency of the bars, and then find an answer. But I think that's going to overcomplicate things. I think we can make life a lot easier by just considering how many squares are representing 6 babies, and how many squares represents the number of babies you have to find, and then we can use simple proportion. So if we consider the squares in this section over here, we have 5 times 4, 20 squares. And in the section over here, we have 5 and 5. There's 10 squares altogether between 4 and 5. 20 plus 10 is 30. So we can say that the 6 babies, they're being represented by 30 squares. Okay. And that's, we can work out from that. And we've got to work out how many babies are represented by the rest of the squares here, so we can count these squares as well. And it won't take too long to do so. I'm just going to change the color. So we have here, again, this is again 20. That's 5 times 4, that's 20. And here we have, this is this time 4 times 5 up to here. That's going to be 20. And that's another 20. And that's another 20. And that's another 20. All right, so we have, I'll just put the totals on top, 20, 40, 60, 80. So that's 100 squares so far. And here we got another 20 here. I'll just do the ones that look easier. That's 20 and 20 and 20, so that's another 60. Okay, and then we got these squares here. So we can see that, if I make those lines as well, that's 5 times 2, that's 10, 10, 20, 30, 40 and 50. So that's 50 there. So we've got 20 plus 80, that's 100, plus 50, that's 150, plus 60, that's 210. So we have 210 squares are representing the number of babies that we want to do. So what I'm going to do is I'll write that on top so it's a bit more friendly for us to calculate. So X babies are being represented by 210 squares. So we can just use simple proportion here. X is equal to 6 times 210 divided by 30. Okay, just kind of cross multiply there. So we could do the following. I know that these can cancel out. I know that 3 goes into 6 2 times. 2 times 21 is 42. So X equals 42 babies. Okay, so 42 babies is our answer. I've shown all the steps here so you can see everything next to the question. Normally you would write the work over here, but the final answer should be written in this place, 42 babies. I think that's far easier than attempting to work out the frequency density of each of those bars and then working out each frequency. I mean, it's possible to do so, but I think it's easier to do this because this is a bit fiddly to do that. So I mean, we could quite easily do this, but we'd have to say that we've got here twice as many babies as in that section here. Together they are 6, so we have to split 6 in the ratio 2:1. There's 3 parts altogether. Okay, so you could say that the first part has to be 2 out of 3 times 6, and the second part is 1 over 3 times 6. That's going to be 4, and that's going to be 2. So there's 4 babies represented here, and there's 2 babies represented there. So if 4 babies are represented there, 4 divided by 0.5 is 8, so that's a frequency density of 8. And 2 divided by 1 is 2, so that's going to be 2. So it works out 2, 4, 6, 8, 10. So that's 10, that's 20, that's 30, that's 40, and that's 50. Those are the frequency densities. So then we can work out the frequencies of each bar. We know that the frequency is frequency density times interval. So we take the frequency density, for example, for this, and we can see that that's going to be 8 times 0.5, which is, that's 4 babies plus, and here we're going to have 40 times, and that's going to be 3. This is going to be 0.4, right? That's 0.4. That's 1, 2, 3, 4. So that's going to be 40 times 0.4. Okay, that's going to be 16 babies. 4 plus 16, and here we're going to have 50. That's going to be 50 times, and that's 0.2. 50 times 0.2, that's going to be 10 babies. Okay, and then we'll have here 30 times, and that's 1, 2, 3.4. Okay, 30 times 0.4, that's going to be 12 babies. And then we're going to have here 30 times 0.4. Yeah, that's it. That's all of them. So that should give us the same answer. That's 20 plus 22. That's 42. So we get the same answer, of course, but I think it's way easier to do it this way. Okay, so you can use the frequency densities. You can use the area of the bars. Whichever way you decide is fine, but I think this is way easier just by counting the squares. So that concludes this question. Question 20 from this paper. Other questions from this particular paper can be found in the playlist at the end of the video, which is linked at the top here. You can find a link for questions dealing with histograms from my IGCSE Edexcel collection over there, which will be quite empty at the moment. You can find histogram questions from my IGCSE Cambridge collection over here. It's exactly the same methods and ideas, so you can benefit from those, and you can subscribe to the channel by clicking on this link. Thank you for watching, and see you soon.